You might have heard some buzz about the James Webb Space Telescope. You might have even seen this gorgeous image that was released to the world last week. That image was just a teaser, though. Today, we get to see the full power of the James Webb Space Telescope as NASA releases another amazing image showing us one of the pillars of creation in the Eagle Nebula. But what are the pillars of creation? Let's find out right now. This is the second science image released by NASA from the James Webb Space Telescope. What we see here is a small region in the Eagle Nebula, also known as Messier 16, about 7,000 light-years away in the constellation of Serpens. This is one of the most well-known images in all of astronomy, the original photo taken by the Hubble Space Telescope in 1995. And here is the James Webb Space Telescope's view of the same thing. Do you see the difference? These structures are made of gas and dust. They are stellar nurseries where stars are born. The reason they look like this is because of the way the light got distorted as it passed through the dust clouds. A small star is visible in the bottom center of the frame. It is relatively young, perhaps a few million years old. Surrounding the star are rings of dust. As gas and dust collapse around a star, it forms a disk. The inner part of the disk heats up so much that the material can no longer remain in a solid state and becomes ionized. It blows away. Eventually, the solid disk becomes transparent and the star is able to emerge and begin shining. Stars form in clusters. In the case of the Eagle Nebula, there are hundreds of thousands of stars in the entire complex. These stars will run out of hydrogen fuel in a few billion years. At that time, their intense energy will blow away the remaining dust, leaving behind beautiful blue planetary nebulae. Within these pillars are three distinct areas with different properties. The top two are more compact and dense, whereas the one at the bottom is more extended with cavities blown by stellar winds from hot young stars. There is also a bubble seen on the left side of the image, created by strong stellar winds from a Wolf-Rayet star. Wolf-Rayet stars are very massive stars that are at the end of their lives. They often exhibit strong stellar winds that can blow bubbles into the surrounding gas and dust. The pillars of creation are about a light-year across. They are not called the pillars of destruction for nothing. Stars in the pillars are constantly being destroyed and created. New stars trigger the destruction of older stars. These pillars were probably captured here at a rare moment of calm before the next outburst of stellar winds or supernova blast waves sweeps through them. This image covers an area of 1.5 arc-minutes by 1.5 arc-minutes, about half the size of the full moon in the sky. Webb can distinguish details as small as 1 arc-second across, about 1/8 of the diameter of the full moon. The JWST is a space telescope designed to conduct infrared astronomy. As the largest telescope in space, it has instruments with high resolution and high sensitivity. With these, it can view things that are either too old, too distant, or too faint for the aging Hubble Space Telescope. JWST will enable investigations across many fields of astronomy and cosmology, such as the first stars and galaxies, the formation of planetary systems, the atmospheres of exoplanets, and the search for life beyond Earth. The Webb was launched on 25th of December 2021 on an Ariane 5 rocket from Kourou, French Guiana. It arrived at its destination, a solar orbit near the Sun-Earth L2 Lagrange point. The James Webb Space Telescope is equipped with 4 scientific instruments. First is the near-infrared camera, or NIRCam, which captures near-infrared light from about 0.6 to 5 microns. This lets us see back to the first galaxies and find the building blocks of planets. Next is the near-infrared spectrograph, or NIRSpec. This instrument uses spectroscopy to analyze the chemical properties of distant objects. It splits light up into different wavelengths, or colors, and then records the amount of light detected through each wavelength. The third instrument is the mid-infrared instrument, or MIRI, which works similarly to the NIRCam but focuses on longer infrared wavelengths, from about 5 to 28.5 microns. This helps researchers learn more about cool things, like stardust and the organic molecules that could be the building blocks of life. Finally, there is the Fine Guidance Sensor, or FGS. This instrument uses visible light to help guide the telescope and keep it pointed in the right direction. It also acts as a camera, taking pictures in the near-infrared spectrum from about 0.6 to 5 microns. The James Webb Space Telescope will primarily observe in the infrared spectrum, which is longer in wavelength than the visible spectrum used by the Hubble Space Telescope. The longer the wavelength the telescope is designed to observe, the larger the information-gathering surface, mirrors in the infrared spectrum or antenna area in the millimeter and radio ranges, required for the same resolution. The wavelength range of JWST's instruments means that it will need a larger collecting area than Hubble to achieve the same resolution. Thus, JWST's mirror is larger, having a diameter of 2.7 times larger than the Hubble Space Telescope. However, Webb will only produce images of comparable resolution to Hubble because it observes in the infrared spectrum of longer wavelength. The Webb's mirror is made of 18 hexagonal segments. Each segment is made of a metal called beryllium and coated with a thin layer of gold. Gold is an excellent reflector of infrared light. The beryllium also provides the necessary strength and stiffness to hold its shape under the extreme temperatures and forces of space. The gold-plated mirror segments come together to form a single monolithic mirror that is 6.5 meters in diameter. The mirror segments are mounted on a structure called the optical telescope element, or OTEL, which also contains the telescope's focus. Light from the mirror passes through a series of filters and lenses before reaching the detectors. The filters and lenses correct for any distortions in the incoming light and direct it to the 4 instruments. James Webb's instruments will operate in the temperature range of 77 to 80 kelvins. To reach these cryogenic operating temperatures, the telescope uses a multi-layer tennis court-sized sunshield made of 5 layers of aluminum-coated Kapton film. The sunshield protects the scientific instruments and mirrors from the sun's heat and radiation. When the telescope launched, the sunshield was folded up to conserve space in the rocket's payload volume. Once in space, the sunshield was deployed in a series of carefully choreographed moves that took several days to complete. The entire telescope is mounted on a structure called the spacecraft bus. The bus provides power, communications, and other support functions needed to operate the telescope. It also contains the propulsion system, which keeps the telescope in orbit around the L2 point. Webb was developed by NASA in partnership with the European Space Agency and the Canadian Space Agency. NASA's Goddard Space Flight Center in Maryland managed Webb's development. The Space Telescope Science Institute in Baltimore, on the Homewood campus of Johns Hopkins University, will operate Webb. The primary contractor for Webb is Northrop Grumman. Webb was named after James E. Webb, who was NASA administrator from 1961 to 1968. During his tenure, he oversaw the launch of the first human spaceflight program, the Apollo program, which landed astronauts on the moon. And there you have it, one of the pillars of creation in the Eagle Nebula as imaged by the James Webb Space Telescope. If you think this is cool, wait till you see what else this baby can do. Let me know in the comments section what you want to see imaged by the James Webb Space Telescope. Don't forget to subscribe so you don't miss out on future videos. And as always, thanks for watching.
Digital magazine wonders of nature. Fascinating articles. Stunning photographs. Delivered in PDF format. Get them in the links of our channels. Purchasing digital magazines is a good way to stay informed.